We're going to start with a quick review on quadratic functions before we get started into some new concepts. Number one review problem says solve for x. Remember, we have a couple options to solve for a quadratic function. We could graph that function and find where the parabola crosses the x-axis, because remember, solutions, roots, x-intercepts, they all mean the same thing. We could also try to factor this quadratic equation, which we are able to factor this because factoring x squared minus 7x minus 18 equal to 0, I look for factors of 18 that subtract to be 7. So I can factor this equation using those two factors of 9 and 2. And remember, this is equal to 0. Then I need to create a negative 7x in my two middle terms. That means I have a negative 9 plus 2. Then using that zero product property, if I have x minus 9 times x plus 2 equal to 0, that means one of those two factors is equal to 0. So either x minus 9 equals 0 or x plus 2 equals 0. So I get solutions of x equal to 9 or negative 2, because remember, I'm going to subtract 2 from both sides here and add 9 to both sides here. So that is your second option to do. Third option would be to use the quadratic formula. Remember, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. After substituting in those a, b, and c values, we would get x is equal to negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times negative 18 all over 2 times 1. After simplifying this down, you should get it all the way simplified to 7 plus or minus the square root of 121 over 2. And then doing the one option of adding on the square root, which the square root is equal to 11, and the other option of subtracting that square root, you should get answers of x equals 9 or negative 2. So any of those three methods would work to solve a quadratic function. The second review of problem, finding the vertex. Remember, to find the vertex of any quadratic function, we use that formula of the x value is equal to negative b over 2a. So in this situation, I would have negative 8 over 2 times 1, because remember, this is like a 1x squared. So then I had negative 8 over 2, or negative 4. Remember, this is just my x value of the vertex, so now I have to substitute it back into the equation. Wherever I see an x, I am now going to put a negative 4 to find the corresponding y value of that point. Because remember, a vertex is an x comma y point. So I have negative 4 squared plus 8 times negative 4 minus 7. Then after doing this, you should get negative 23. So your point is negative 4 comma negative 23. Number 3, factoring that polynomial. It's also specifically a binomial because there are two terms. With factoring, I always check for greatest common factor. There's no GCF between those two terms. When I have two terms, the only way to factor it is if it's a difference of two perfect squares, which in this case it is. So to factor a difference of two squares, I have square root plus square root times square root minus square root, because the square root of 36x is 6x. 6x times 6x would be 36x squared. The square root of 49 is 7. Quadratic functions can have 2, 1, or no real number solutions. And remember, this is the case because if I have two solutions, that means that I'm crossing the x-axis in two spots. So this would be an example of two solutions. If I'm talking about a quadratic function that has one solution, this means that it's crossing the x-axis only in one spot. So that would look something like that. And then if I have no solution, that means that my quadratic function is never crossing the x-axis, so this would be a no solution. We talked about what those all look like on a graph. Now, if I would want to find that out just algebraically, so not graphing, there is a way to do that. We can use a quadratic formula, which remember, that quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, remember, square roots cannot be negative. So if I look at only this part of my quadratic function, that b squared minus 4ac, it's under the radical. It's under that square root sign. So it can't be negative. If that chunk would turn out to be negative. That means that there would be no solution because I can't take the square root of a negative number. So if b squared minus 4ac is negative, or if it is less than 0, there are no real number solutions. We can also find out some other things with that. If under that radical is equal to exactly 0, there's only one real solution, because you're going to be adding on just 0, because the square root of 0 is only 0. It only has one option there. So there's just going to be one solution. And then, of course, if that b squared minus 4ac is greater than 0, we will have two options, because if we take the square root of a positive number, you're going to have a negative and a positive answer. So in that case, there will be two solutions. So if we look at only that b squared minus 4ac, we can decide, and remember that b squared minus 4a squared is called the discriminant. So we'll be able to tell just on that discriminant if our parabola is going to have 1, 2, or 0 solutions. So looking at these two examples, the first thing we need to remember, though, when we're talking about quadratic functions is our quadratic function should be set equal to 0. And as you notice in this first example, 2 squared minus 3x equals negative 5. It is not equal to 0. So remember, to get it equal to 0, I'm going to move this negative 5 to the other side by adding it, opposite operations. So my quadratic function is 2x squared minus 3x plus 5 equals 0. Now I can look at that discriminant to find out how many real number solutions it has. And remember, the discriminant is just that chunk of b squared minus 4ac. My b value in this function is negative 3, so I have negative 3 squared minus 4 times the a value of 2 times the c value of 5. Negative 3 squared is 9. Negative 4 times 2 times 5 is a negative 40, so this is equal to negative 31. Since that chunk is negative, remember that's the chunk that's going to be under the square root sign. Since it's negative, I will have no solutions here because I cannot take the square root of a negative number. So there's no solutions in that quadratic function. Moving on to the next one. Same thing here. This is not set equal to 0, so I'm going to subtract 7 from both sides and look at my quadratic function of 6x squared minus 5x minus 7. Once again, looking at that chunk, that discriminant chunk up here, b squared minus 4ac, my b value is a negative 5, so I have negative 5 squared minus 4 times the a value of 6 times the c value of negative 7. Negative 5 squared is 25, and then I'm going to have 25 plus 168, because negative 4 times 6 times negative 7 is 168. And then adding those two together, I'd get 193. 193 is greater than 0. It's a positive number. So in this situation, I'm going to have two solutions because that square root will be a positive number, and there's two answers to the square root of a positive number, so I'll have two solutions in this situation. All right, these next two examples say solve. So you are either factoring, if you are able to, with this set equal to 0 and using the zero product property, or you're using the quadratic formula. In this first example, I'm going to use the quadratic formula because the x squared function has a coefficient of 2, so I don't really want to factor that because it's going to have a few more steps. So I'm going to use the quadratic formula of x equals negative b, so my b value is negative 9, so I have negative 9 plus or minus the square root of b squared, which is negative 9 squared, minus 4 times my a value of 2 times my c value of 12, all over 2a, or 2 times 2. This is going to give me a result of negative 9 is a positive 9, plus or minus, I'm going to end up with the square root of negative 9 squared is 81. Negative 4 times 2 times 12 is a negative 96, all over 2 times 2, which is 4. Simplifying that one step further, I'm going to have x equals 9 plus or minus the square root of negative 15 all over 4. I cannot take the square root of a negative number, so this is going to have no solution here. There is no point in this parabola that's going to cross the x-axis. All right, next example here, we have x squared minus 2x plus 3 equals 0. It's set equal to 0, so now I can either factor it or use the quadratic formula with whichever method you choose to use. If you choose to use the quadratic formula, you would be having something x equals negative b, because negative 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times my a value times my c value, all over 2 times a. This simplified further is equal to 2 plus or minus the square root of 4 minus 12 all over 2. And then also with this situation, we would have x equals 2 plus or minus the square root of negative 8 over 2. So I'm trying to take the square root of a negative number, which does not work. So with this example as well, we would have no solution. If you chose to use the factored form, trying to get this in factored form, you would look for factors of 3 that add up to 2. There are no factors of 3 that add up to 2, so I cannot factor this any further, so I cannot find a solution here. How many solutions? Remember, we're using that discriminant, that b squared minus 4ac, to find out how many solutions these quadratic functions have. Remember, if this is equal to 0, that discriminant, there's going to be 1 solution. If that discriminant is greater than 1, if it's positive, there's going to be 2 solutions. And if that discriminant is less than 1, it's negative, then there will be no solution. So in this example, we have b squared, 3 squared, minus 4 times the a value of 1, because remember this is like a 1x squared, times the c value of 11. So then we have 9 minus 44, which equals negative 35. So in this case, we would have no solution. Now I want you to pause the video and try the second example out on your own. Hopefully with this second video, after you've tried it on your own on the second example, you got something like 12 squared minus 4 times 9 times 4, or 144 minus 144, which equals 0. Since this discriminant is equaling exactly 0, that means that there is 1 solution for this quadratic function. Because remember, if I take the square root of 0 in that quadratic formula chunk of the discriminant, there's only going to be 1 answer. Square root of 0 is 0. Lastly, looking at some story problems. So it says a batter strikes a baseball. The equation y equals negative 0.005x squared plus 0.7x plus 3.5 models its path, where x is the horizontal distance in feet and the ball travels, and y is the height in feet of the ball. How far from the batter will the ball land? Round your answer to the nearest tenth of a foot. So we want to know the height, when the height will be 0, because we want to know when that baseball's height is 0. We want to know when it's hit the ground, and therefore then it'll tell us what distance that baseball is from the person's traveled. So we want to know, when is the height equal to 0? So height in this situation is y. So we want to know when this chunk will be 0. Well, if I set this equal to 0, then I'm now solving a quadratic function, so I'm going to use that quadratic formula of negative b plus or minus the square root of b squared minus 4ac all over 2a. So now that quadratic formula is going to look something like negative my b value plus or minus the square root of my b value squared minus 4 times a times my c value all over 2a. Now you're definitely going to want your calculator handy for this problem because we have some decimals in here and we're going to have to be rounding some answers. So this next simplified version of this quadratic formula is going to be negative 0.7 plus or minus the square root of 0.49 plus 0.07. Remember, we have to follow order of operations. So under that radical, I had to square the 0.7 first, and then I had to do all that multiplication before I can add or subtract within the radical. Then down below, doing that multiplication, we have negative 0.01. One step further, adding that 0.49 and 0.07 in the radical. So we have negative 0.7 plus or minus the square root of 0.56 all over negative 0.01. Remember, we're going to have two options because I have to do negative 0.7 plus the square root of 0.56 divided by negative 0.01, and I have to do negative 0.7 minus the square root of 0.56 all over negative 0.01. This is going to give me two answers, and those two answers are going to be about negative 4.8 and about 144.8. Now, if I look back at the question, it says, how far from the batter will the ball land? Now, it does not make sense to have this negative answer. I can't say that the ball is going to land negative 4.8 feet away from the batter. So I know that that answer is not applicable in this story problem. So this 144.8 is going to be my answer that makes sense to the problem. And in the original problem, it told me that this distance was in feet. So I have about 144.8 feet away from that person the baseball has landed. Now I want you to try out this next example of Jacob tossing a football on your own. I want you to pause the video, try and use that quadratic formula to find out how far from Jacob the ball will land. So remember, you're going to set it equal to 0. So pause the video and try this out on your own. After plugging into that quadratic formula, you should have gotten something like x is equal to negative 0.75 plus or minus the square root of 0.75 squared minus 4 times negative 0.05 times 4 all over 2 times the a value of negative 0.05. Simplifying even further, you should have been left with a simplified version of negative 0.75 plus or minus the square root of 1.3625 all over negative 0.1. That should have resulted in two answers of x is equal to about 4.17, negative 4.17 and 19.17. Once again, I'm talking about how far away from Jacob will the ball land. So a negative answer does not make sense in this story problem. So my final answer is about 19.17 meters because in the original problem it told me my distance in meters.